What are you doing?
Looking good.
He Everybody, it's your boy Joe coming in loud and clear. We're gonna have some fun today, I promise you that. I need to give a big shout out to thank you very much. Shout out to you, yo. So, I'm coming in multiple dimensions. We're going to be implementing some IPv6 on some routers on Cisco Lab today. Let's get ready to do this, everybody. Hopefully, you guys can join me out there. We're almost at affiliate, guys. Let's get by the end of this week. Let me fix my hand. Let me fix my hand. Everybody's doing really good today. Alright, yeah, that to the biggest. Let me take my mask off.
Everybody, this is your captain speaking here. Like I said, today we're going to be implementing IPv6 on routers inside of Cisco Model Lab. So, if you don't mind, please strap into your seatbelts and let's take this ride into a chapter, a 24, implementing IPv6 on a router.
Alright, we're back. Enough of that. I have too much fun with that now. Alright. How's everybody doing, though? Hope everybody's having a good day. I'm feeling a little off today, but you know what? We're not doing too bad. Just change the lighting a little bit. Need to get a better base light. That's what I need to do. My hat's all fuzzy. Alright. So, like I said, we're going to just dive right into it. We're going to do a quick review, though. Get this over here. Alright. We're going to do a review, though, on what we've studied so far. So, we're going to jump over to Pearson, guys, and we'll just review just a couple of chapters that we've gone over so far. Let me stop the music real quick. Music does get distracting. All right. Let's go over which scene would be the most appropriate for the intermission. All right. Like I said, let's jump over to Pearson real quick, and we'll do a review on just what we've learned, well, at least what we've covered so far. So what do we got? We got fundamentals, an IPv6 addressing in subnetting. We won't do these two because we haven't reviewed those yet. But like I like to do, I like to do a review just to keep the just to keep the it fresh in my mind. You know what I'm saying? It's good to keep on doing these things. And yeah, so shout out to revered dude, good looking out. I appreciate that. Supporting the stream and stuff like that. That was big. That was real big. And that's awesome. You're an awesome person. And you know, I from my family to yours, you're helping support this dream that I'm trying to put together here. So I really do appreciate that. All right. And shout out to ABC WAN too. ABC WAN trying to do his thing. Shout out to ABC WAN. Good looking out on the raid yesterday. Yeah, you guys are all awesome people. Everybody out there has been super supportive to this stream so far, and I just without trying to get too emotional, I'm just super encouraged and super pumped up by the support and the encouragement and the feedback that I've been getting from everybody. Gamer Golf, you know what I'm saying? Yesterday was super encouraging and gave some great feedback and some awesome encouragement. So yeah, guys, I just wanted to just say thank you. You know, you guys are all awesome, and you continuing to make this dream real for me. So, all right, let's jump into doing some practice tests here. All right, which of the following answers are true about the rules for abbreviating IPv6 addresses? So we have to select two answers. Okay. So what do we got? Multiple consecutive groups of zeros between two colons can be replaced by colon in multiple locations in the address. No, it can only be done once. All right, trailing zeros within a set of 4 hex digits between can be renewed. Nope, only leading zeros. Abbreviating the process of making the IPv6 address backward compatible to IPv4. Nope. Multiple consecutive zeros between two colons can be replaced with colon in one location of the address. Yes. Leading zeros within the set of 4 hex digit between two colons can be removed. Yes. Okay. How many subnets can be created from 1 hex character in a IPv6 address? How many subnets can be created? How many subnets can be created from 1 hex character? From 1 hex character in an IPv, we'll go with 16, right? Yeah, 16. All right. Which of the following is not a solution? Which of the following is not a solution to the IPv4 address shortage problem? So which is not a solution to the shortage problem? So we only one answer. So more careful and reduce address assignments to businesses. NAT is a solution. Subnet broadcasting, the development. More careful and reduces. That one's just awfully written. More careful and reduced address assignment to businesses. What is not a solution? Subnet broadcast addresses? Sure. That was just a weird question. All right. Which of these is a correct representation of an IPv6 address? Okay, what do we got, guys? We got 1, 2, 3, colon, 4. That's wrong. All right, that's wrong because of this right here. See how there's two colons, so you can only do that once in an IPv6 address. So we got 1, 2, 2, 3, 4, 1, 2, 3, 4, 5. Yep. This might be right. Let's go 1, 2, 3, 4, 5, 6. Is there a colon? Is there a double colon in here? I know I'm not seeing a double colon in here, so this one's wrong too. That one's wrong. That one's wrong. One, 2, 3. So it's between these two right here, guys. Oh wait, this one's wrong. That one's way wrong right there. Do you guys see what I'm saying? There is no W, Y, or Z in hex. W, Y, or Z. So this one's wrong. Okay, so it's this one right here, guys. Okay. Select that one, guys. Clear the board. That was a good one. That was actually really good. Made me think a little bit. All right. Which of the following answers are valid abbreviations of the address? Okay. Let's write this one out, guys, so we don't biff it. All right. Which is an abbreviation? So we have 2000, right? Let me move my thing a little bit so it's not in the way of what we're trying to do. Colon. We can say 1, right? We can say 2, colon. Because remember, we can remove leading zeros. We can remove leading zeros. So we have 3. And what else we got? We got 0, 0, 0. So we can do a double colon here. Okay, removing these groups of zeros. Okay, but this is the only time we can do the double colon, and then that's it. All right, and then we have 1, 1, 1, 1, 0. Oop, too many ones, brother. And then colon 2, 2, 0, 0. All right. So this is our abbreviated address. So what can we match this up with? Nope, not that one. Perfect. That one right there. So the first one, guys. So see how we matched it up? And then we can use the double colon once right there because of these zeros right here. All right. But then that's it. All right. So let's choose the first one. Oh, where did I go wrong? Leading zeros. Is that a quartet? It's removing leading zeros. Single. But where did I didn't remove anything. That's just, in this case, 2 consecutive quartet zeros is this. So those 2. Oh, select 2 answers. So I was right. Oh, that's what I get for not reading. Yeah, that would have been right, but I went. That's fine. I didn't read the select 2 answers. How's that? That one is correct. It just didn't remove the double zeros. Okay. I accept that because of my unreading. All right, move on. And that's a bummer because I wanted to get these all right, but it's fine. All right, let's just take a sip of coffee. All right. Host A is host A in one Ethernet VLAN needs to communicate using IPv6 to host B, which is in another Ethernet VLAN. Which answer best describes the protocol used by host A to learn the layer 2 address of host B? Host A is so it's ARP, right? Oh wait, this is Oh, wait. ARP is not used, and it's Neighbor Discovery Protocol. Neighbor Discovery Protocol. So NDP, Neighbor Discovery Protocol. Okay. Ah. Did I not read this right? Like IPv6, IPv4 needs to know layer 2, yet another host in the same subnet, but not host in another subnet. The question states that host B is in a different Ethernet LAN, so it would be different. Subnet, I would say, at least for the router, layer 3 switch, layer 3 between host A and host B results in a host A never. All right, I get that. So it's pretty much explaining, and I guess I didn't read it correctly, because so we can kind of like draw this out. So say we had a couple of let me grab a circle. Actually, delete this one, delete that one to make this a little bit bigger. Not that big. So say we had a router, because here we go. So host A is in a different one, and then we had this one. Communicate to Ethernet LAN protocol. It's pretty much just explaining that host A, host B. What it's describing in this topology here, and I guess I didn't read it right, is they're split off on different VLANs. So say this is VLAN 1, and this is VLAN. I put an exclamation point there. VLAN 1, this is whatever VLAN 2. And what it's stating is if host A is in a different Ethernet VLAN and needs to communicate using IPv6 to host B, which is in another Ethernet LAN, which best describes the protocol used to learn the layer 2 addressing. So what it's pretty much covering is because this is a layer 3 switch. All right, so this would be a layer 3 switch here. All right, so this is a layer 3 switch. So remember, layer 3 switches do handle routing protocols and do handle routing and stuff like that. Okay, so if host A needs to learn, obviously, like host B, so this layer 3 switch is going to act exactly like a router. How even though if host A sends the NDP message over to the layer 3 switch, the layer 3 switch though is in its ARP table, in the layer 3 switch's ARP table. That's where that layer 2 information is going to be held. Or yeah, if the layer 3 switch is acting like a router, so if you have it set up like a router, when you configure it as a routing interface, it'll have an actual ARP table. You know what I'm saying? It will have a MAC address table too, but it'll also have an address resolution table too as well. But that address, that layer 2 address though, would only be held here at the layer 3 switch, and that it will not be on the host A. Okay, that's what this is describing here. Even though yes, IPv6 uses neighbor discovery protocol and not ARP, that's where I got hung up. All right, so I just wanted to explain that just because I guess I didn't read this correctly. I guess I was just rushing through it, but this explanation is correct. Is correct. So again, ARP is an IPv4 protocol to learn local device layer 2 addresses, and it isn't used in IPv6. NDP, Neighbor Discovery Protocol, NDP, all right, is used to learn layer 2 Ethernet addresses when needed, but only functions within the same VLAN. The same VLAN, okay? OSPF version 3 is a routing protocol used by routers. So it does learn information about IPv6 subnets, routes in those subnets, but it isn't a protocol to learn layer 2 addresses of a neighbor. Again, because they're in different Ethernet VLANs, okay, they're in different Ethernet VLANs. Pretty much this layer 3 switch is acting as a separating router between those devices. Okay, so that this will have the information on it. None of the host will actually have that layer 2 information held on there. Okay. I just wanted to explain that just again, because that explanation did shed some light on how I got that wrong. So, all right. IPv6 represents a binary IPv6 represents a binary IPv6 address. Yeah, I know. Using hex characters. Which of the following binary strings represents CE? CE. So we'll write out the so yeah, you guys can see me. So remember we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then when we get over here, all right, we'll go back up. Then when we have once after 9, we have caps A, B, C, D, E, F. All right, and that's represented by 10, 11, 12, 13. Whoa. 14. Oh, I forgot one number actually. 15. A 0. So I forgot the 0. I always forget the 0 for some reason. I don't know why. So this is hex right here. So 0 through 9 are the, you know what I'm saying? This is easy numbers for us. But then obviously 10, 11, 12, 13. So CE. So CE. So if we needed CE, so if we were to come over here to our, which calculator is it? To be our programmer one. So if we go to hex and we were to do CE, all right, and we would go back to how it looks in binary, all right. So this would be the representation of CE in binary right here, okay. So it'd be this answer right here, guys. You guys see how I did that? All right. And that is because so that is just simply what it is representing. Okay. That's all it is. Clipboard. All right. Which of the following subcutaneously that's a crazy word. Describes the specific address range typically used by the IANA for the global IPv6 addresses. Which of the following describes the specific address range typically used by the IANA for the global? So global, remember, is public IPv6 addresses. Which one was it, guys? For some reason, I want to select this one. We're going to select it. See where we're wrong. And we're wrong. Okay. Let's read into it. All IPv6 routing prefix assigned by the IANA begins with 2 or 3. Okay. This address range can be written as a prefix 2000::/3. This means that the first 3 bits must be 001, and hex the first group of numbers will be in the range of 2000 through 3FFF. All right. 2000::/2 indicates that the first 2 bits must be 00 without any control over the third bit, which needs to be on. 2000 Delta Bravo 8::/16 is an address range targeted for use in documentation, so that we don't use other people's addresses for examples containing in training or generic purposes. FE80 are local addresses, link local addresses. Okay, so yeah, so let's just keep that, I guess, in our memory banks. That might be a difficult one for us to remember. All right, but the 2000::/3 is the IANA global IPv6 address. So let's keep that again in our memory bank. So the 2000::/3 is the IANA global IPv6 address. Okay. All right. Let's make sure we don't forget that for next time. All right. Which IPv6 address represents a global IPv6 address? So not that one. We got this one. And for some reason I'm on the fence between these two right here. I know for wait. This is DV8. That goes back to what that was just describing before, right? IPv6 is so confusing. Gotta love IPv6. Makes my head hurt. Good. Hey, we were right. That was a shot in the dark. Identifying the first hex digits for a link local address. Identify the first hex digits of a link local address in IPv6. So it's this one right here. Example of the output, the show IPv6 interface brief command shows the exhibit. What 2 addresses are shown? Let's take a look at the exhibit. So we have a unique, all right, and then we have a link local. Unique and a link local. All right, link local. Obviously that's represented by the FE. All right, and then the unique is represented by the FD. Okay, if your ISP assigns you prefix 2003:1234: Alpha Bravo Charlie Delta: 6600: 50/56. How many bits do you have to create your own subnet? So again, we can write this out really quick. All right, so you guys can take a look at. All right, let's make this that big. Okay, so if we had 2003:1234: ABCD: 6600. So what do we got? 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 4. All right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Very good, eh? All right. All right, and we had 56 bits. All right, so remember, 16, 16, 16, 16. So where does that get us, guys? All right, let's draw a line. So if we had, so 16, 32, 48, all right, and then 48 plus 16. Simple arithmetic escapes me, guys. So that gets us to 64. So somewhere in this quartet here lies where our prefix ends, okay? So what's minus? So it'd be right here, guys. So our, back that up, different color. So this is where our, this is pretty much where our prefix ends right here, all right? So then we have all these other bits to manipulate, okay? So we have 16, assigns the prefix, how many bits can you create? How many bits do you have to create your subnet? So giving that the fact that we're still gonna maintain the /64, because I'm pretty sure that's what it's getting at. How many bits do we have left over? So what it's pretty much getting at, and I think this is what it's getting at, is these 2 bits right here, okay? So how many bits do we have left, all right? So that gives us 8 bits, because each one is represented by 4 bits each, okay? So we have 8 bits, all right? And that was correct, okay? All right, because what it's pretty much covering, what that was getting at was everybody's using the /64. So even though we could subnet all the way down, but that's what that was representing. We did okay. We didn't pass. We got a couple of the we how's this? We got one that we should have got right, and we got a couple other ones that were just I biffed up on the concept of the addressing and whatnot. All right, take a sippy of my water. All right, let's get into it. We got. Just refresh my host. I got to get rid of that timer. I don't like that timer. I just want it to stay on. All right, so we got CML up. How many routers am I gonna need? I just wanted to see what kind of. So this was the lab we were working in yesterday. We're gonna make a new lab. Let's call this lab IPv6. Oh, I still got caps lock on. IPv6 implement. Implement on router. We'll just go IPv6 implement. Okay. Cool. Happy with that. And then, like I said, if you guys are interested, to getting these configuration files and taking a look at them, remember to join my Discord. Here, I'll throw my Discord link in the chat. All right. If you're interested in taking a look at these configuration files, guys, remember to join the Discord, and then you can always take a look at these when I post these on Git. So remember, once you join my Discord, just real quick, because I don't know if people are getting confused about when they join the Discord, but right here, guys, this is where you're probably gonna end up on this page first. Okay, you're not gonna see any of this. Okay. You're gonna come right to this page first, okay? It's gonna ask you it's just gonna go over some of the information, but then you're gonna scroll over to the rules page, guys. All right. And this is right here. This is all I'm asking that everybody just takes a read at and agrees to it. And then once you click on this little green check mark, guys, you will then be assigned a member role. And then once you become a member, you'll then be able to see all of the other channels, guys. All right. So I don't know if people have been getting confused about that. Like they come to my Discord and they only see these first three pages. That's because this is the start here, guys. Okay. And all I'm asking is you just read the rules, and then you just click on the green check mark here. Okay. And once you do that, then you'll be able to see all the other information. All right. Well, all the other channels on the Discord page. All right. And I got all kinds of cool stuff in here, guys, and I'm continuing to add stuff. You know what I'm saying? I got network feed. This is the network feed channel, and I follow. This is me. This is the couple of the networking guys off of Twitter. So David Bumble, Nick Russo, IT Pro TV, Kevin Wallace, Kevin Baker, Keith Baker, Jeremy. All right. I even got a really there we go, Chuck Black. He's really awesome. Chuck Black is super intelligent. If you're into Python programming and whatnot, Chuck Black is definitely the guy that you should be following and whatnot. I also have a couple of this is my promo corner. This is just some of the gooses. So if you're a goose out there, you'll know what I'm talking about. These are just some of the gooses that I promote their streams on. And then the networking guys that I follow, if they have a YouTube page or a Twitch account or anything like that, I also promote their work here on this page here too, guys. And then as well too, and I invite you guys to promote yourselves too on the promote your stream or your YouTube stuff as well. So I'm definitely, I want you guys to be promoting your stuff too as well, because I would love to take a look at your guys' work as well. And down here, guys, this is some Reddit feeds. I created this right here, guys, just so you guys have some, if you have just casual reading, you know what I'm saying? That's a lot of why I've done what I did with my Discord. With a lot of I love my Joe bot. What I've done is I want it to be where you guys can just, if you guys have time, just casual read. You know what I'm saying? I follow the CCNA Reddit, the VMware Reddit, the SysAd Reddit, Home Lab. You know what I'm saying? The Linux one, the networking one. The only reason why I'm following the Nutanix one is because of what's going on between Nutanix and VMware right now, with the CEO leaving VMware and going over to Nutanix. There's just some of the interesting stuff that's going on between those two companies right now. So again, you know what I'm saying? If you want to take a look at it, go right ahead, guys. But this is what I'm talking about with the Cisco Model Lab. So when I upload, I didn't even log into Git yet. I gotta log into Git real quick. When I drop those files into Git, my Git repository, when I drop the because the lab, I can download the lab from CML and it comes up as a HTML file. And if you're not familiar with HTML is YAML. HTML. It's a YAML file. I said HTML. It's a YAML. If you don't know what YAML is YAML ain't markup language. If you're used to programming languages and whatnot, YAML is like tucked in between like HTML, web pages and stuff like that. Sometimes depending on what kind of what you're doing and stuff like that. But it's used a lot. It's used a lot in Ansible. So if you're familiar with anything Ansible, YAML is how you write your playbooks. You write it in YAML files, okay? So you can actually take these configuration files off of my Git, all right, and then actually implement that into a Ansible playbook, all right? It's super cool how you can do that with Cisco Model Lab, because it structures it perfectly, that you can actually take it create an Ansible playbook with it too. But again, that's if you're into Ansible and automation and stuff like that. Those are a little bit of advanced topics and stuff like that. But those are topics that we're going to be getting shortly into as the stream develops too, guys. Okay, so there you go. So that's the little snippet of that I just wanted to lay out with the Discord here, because I don't know if people were getting confused when they came here and they got here and they couldn't see anything else. It's because all you got to do is you just have to read all this, okay? And then again, you just got to click on this little green check mark here. All right, it even says, click on this check mark below to join Joe's Networking Corner. As a member, unlock the full Discord and verify that you've read and agreed the server rules, okay? Again, the server rules are very simple, guys. I just needed to have some way of making sure that everybody, if they are going to join, making sure that they're joining for the right reasons and not for foolish or mischievous reasons. Okay, so that's the only reason why I had created this little rules things here, guys. Okay, so that's it. That's my spiel. All right, let's grab a couple of routers. We're gonna grab 2 routers and we'll grab a couple hosts. Okay. Make that a little bit closer so we can zoom in. You guys can see the awesomest icons, the beautiful icons. Right. How's this thing calling these things? R1 and R2. Okay. I took caps off. R1. Call you post 1. Let's get these routers fired up. They're going to take a couple minutes to go through. We don't need to turn these hosts on just yet. Those hosts can stay off. They boot up pretty fast. All right. Get your coffee before it turns ice cold. It's already lukewarm. All right, let's get to it, guys. All right, chapter 24, implementing IPv6 addressing on routers. This chapter covers the following exam topics: network fundamentals, compare, contrast IPv6 address types, global unicast, unique local, link local, anycast, multicast, modified EUI64. Okay, so that's one thing that I need to be educated on, is the modified EUI64, okay? Because it does something neat that I need to read into more of, okay? All right. With IPv4 addressing some devices, like servers, let me make sure that, all right. I just wanted to make sure that you guys were hearing me. I get so many mics, well, so many virtual mics now that I get confused which one I have turned on and turned off. Okay. With IPv4 addressing in some devices like servers and routers, typically use static predefined IPv4 addresses. End user devices do not mind if their addresses change from time to time, and they typically learn an IPv4 address dynamically using DHCP. Yes. Okay. IPv6 uses the same approach with server routers and other devices. In the control of the IT group, often uses predefined IPv6 addresses with end user devices using dynamically learned IPv6 addresses. This chapter focuses on IPv6 addresses configurations on routers. The chapter begins with more obvious IPv6 addressing configurations with features that mirror IPv4 features showing how to configure interfaces with IPv6 addresses and view that configuration with the show commands. Cool. All right. The second half of this chapter introduces new IPv6 addressing concepts, showing some showing some addresses used by routers when doing different tasks. All right. So let's do this. Do I know this already? Quiz. I love doing those. Okay. All right. Oh, legs killing me today. R1 has a interface named Gigabit Ethernet 0-1 with MAC address. Whose MAC address? The interface with Gigabit 0-1. Whose MAC address has been sent to yada yada yada. Which of the following commands adds R1's Gigabit Ethernet 0-1 configurations mode? Give this router Gigabit interface unicast IPv4 address. So we just want to give it this address, right? That's all we want to do. I have no idea why there's that. 1, 2, 3, 4, 6, 7, 8. Difference here. 1, 2. What's the difference between what's the difference? What am I not looking at right, guys? So IPv6 address, yep. Oh, there's a space there. Okay, we don't need a space, so it's A. I had to look at that. It was playing with my eyeballs. My eyeballs are broken. Alright. So 1, we're gonna go with A. Alright. R1 has an interface named Gigabit 0-1, whose MAC address has been sent to yada yada yada. This interface has been configured with the IPv6 address. Subcommand. What unicast address will the interface use? What unicast address? This is why I need to learn about this right here, the EUI 60-64, guys, because it has to do with link local addresses. Link local addresses. Love and joy come to you. Let's go with A on that one. 2. But now I'm kind of like between myself on this one, though. I've been sent to unicast. Let's change 1 to B now. Kind of like on the fence with that one. Let's keep it moving. All right, R1's router R1 currently supports IPv4 routing, routing packets in and out of all its interfaces. R1's configuration needs to be migrated to support dual stack. So dual stack is running IPv4 and IPv6 simultaneously. Routing both IPv4 and IPv6. Which of the following tasks must be performed before the router can also support IPv6 packets? Choose 2 answers. So we have C. We know C. So 3. So we know one of them is C. Enable IPv6 on interface using the IPv6, and it's A. So it's A and C. A and C. All right. Router R1 has an let's go over to CML real quick because those, yeah, okay. They were done. I don't want to do that yet because that'll mess it up. So console, say no. Let that finish doing its initial boot. All right. Let those finish doing their initial boot. We'll keep it moving. All right. R1 has an interface named Gigabit 0-1, whose MAC address has been sent to yada yada yada. The interface is then configured with the IPv6 address, the FF yada yada interface. No other IPv6 addresses are configured on the interface. Which of the following answers list the link local address used on the interface? It'd be D, right? It'd be D. I'm gonna go with D on this one. IPv6, guys, it's definitely something that's like alien to me in a way. Only aliens use this craziness. All right, let's not look at the answers. Now I see I was wrong. I was right and I was wrong at the same time. How's that? All right. Which of the following multicast addresses is defined as the address for sending packets to only the which of the following multicast addresses is defined as the address for sending packets to only the IPv6 routers on the link local? Which of the following multicast addresses is defined as the address for sending packets to only the IPv6 routers on the link local? Mind blown. All right. Let's go with B maybe. I'm swinging at the fences at this one, guys. Swinging at the fences. All right. You know, it's funny. I had A. I had A originally. A. All right. This is wrong too. This is B. We'll take a look at it too afterwards. This was right. Hold on. My sons are getting out of control. What's going on? Sorry. My boyos were getting out of control. They play too much Fortnite. Alright. We were definitely way wrong with that one, so that's A. And then we were good on that one. Alright, let's take a look at what we did wrong and what we actually did right. So that was a shot in the dark for me. But FF, so Foxtrot 02::2, multi-address multicast address defined for sending packets only to the IPv6 local routers. And then on the R1's interface named gigabit 0-1, whose MAC address has been sent to 0200 yada 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 yada's interface. All right, and that would be A. And why would it be A? So we have the FE80, obviously like link local. So FE80 link local. All right, and then it's just picking up this, but then it's changing. See, that's what I don't understand. Like, why would that change from alpha to from Bravo to alpha instead of it being this one right here? All right. All right, we got that one right. 2, where did we go wrong on 2? 2 it should have been B, and why should it have been B? Well, let's take a look at it. So it's pretty much jam-packing that link local in between 1, 2, 3, 4. It's not even. So it's pushing that into the which bit is that pushing it into? Because it's something similar to what it's doing it over here too. What bit is that, guys? So 1, 2, 3, 4, 5, 6 bit. So the 6 bit, 6 quartet. 6 times 16 equals 96 minus 8. So the 88 bit. Hold on. My boys are getting crazy on me. All right. That gonna be that kind of a day. So the 88th. So what do we figure? The 88th bit. That's where this is getting jammed into. So right, 88. So on the 88th bit, that's where that's going into. Now, is that the case here too as well? 1, 2, 1, 2, 3, 5, 6, 7, 8. No, it's different again. 1, 2, 3, 4, 5, 6. No, that's the same again. So the 88th bit. So something special about the 88th bit on what these link local addresses are doing. So let's just keep that in mind. So they're going into the 88th bit. And let's see how that correlates as we read this chapter and see if that's what it describes as what this is doing. All right. So that's why I like those do I know this chapter already, quizzes, just because it gives you a minute to kind of like brainstorm what you're going to be reading and to kind of like get you geared up and mentally prepared for what you're going to be doing, and just, you know, seeing if you know this already. All right. Every company is based in its enterprise's network on one or more protocol models or protocol stacks. In early days of networking, enterprise networks used one or more protocol stacks for different vendors, as shown on the left. Over time, companies added TCP/IP based on IPv4 to the mix. Eventually, companies migrated fully to TCP/IP as the protocol stacks, as only the protocol stacks. So again, we've gone over this actual timeline and this theory here. Well, not theory, I guess, how things happened. Okay, the migration. The emergence of IPv6 requires that IPv6 be implemented in end user hosts, servers, routers, and other devices. However, corporations cannot just migrate all devices from IPv4 to IPv6 over one weekend. Instead, what will likely occur is some kind of long-term migration in coexistence in which, for a large number of years, most corporate networks, again, use multiple protocol stacks, one based on IPv4 and one based on IPv6. Again, that's why we have the ability to be running routers dual stacked. Okay, so that's running IPv6 and IPv4 simultaneously. Okay, eventually over time, we might all see the day that when enterprise networks run only IPv6 without any IPv4 remaining. Okay, but that day might take a while. And the figure shows the progression, just to make the point. But who knows how long it will take. So the 2010s, okay, and then we have the 2020s here, okay. So we're running. So we were in you know, just 10 years ago, IPv4 was still the biggest stack protocol we were running, while IPv6 wasn't being so implemented. Now we have, you know, somewhat where it's half, and then we're looking the next maybe 10 to 20 years from now, where IPv version 6 may take over, at least on the enterprise level. All right, so that's what this is describing. So possible path through dual stack IPv6 and IPv4 over the long-term period. One way to add IPv6 support to an established IPv4 based enterprise internet network is to implement a dual stack strategy. To do so, the routers can be configured to route IPv6 packets with IPv6 addresses on the interfaces, while a similar model to how routing supports IPv4. Then a host can implement IPv6 when running both IPv4 and IPv6 dual stack. The first major section of this chapter shows how to configure and verify unicast IPv6 addresses on the routers. So static unicast address configurations. Cisco routers give us two options for static configurations of IPv6 addresses. In one case, you configure the full 128-bit address, while in the other, you configure a 64-bit prefix and let the router derive the second half of the address. While you configure, Cisco routers give you, in one case, you configure the full 128, while in the other one, you configure the 64 prefix and let the router derive the second half of the address, the router interface ID. The next few pages show how to configure both options and how the router chooses the second half of the. All right, so that's what I was reading earlier today about, and that's what I needed. That's what I really need to dive into, is this process right here. All right. To configure the full 128-bit address, to statically configure the full 128 address, either global unicast or unique local, the router needs an IPv6 address prefix length, interface subcommand on each interface. The address can be abbreviated and in an abbreviated IPv6 address with the full 32-digit hex address. The command includes the prefix length value at the end with no spaces between the address and the prefix length. The configuration on the router's interface IPv6 address really is that simple. Cool. Along with the example, it shows the basics. So the basic example, the figure shows the global unicast address, IPv6 address used by two different interfaces. Yada yada yada, as usual with the / subnet of 64. Okay. Let's continue on. So here's a code snippet. So we have in the global configuration mode, we have the IPv6 unicast routing, and then into interface, then the sub interface command, the interface gigabit 0-0 here, and we have the assigned address, and there it is on router 2. All right. The configurations on one of both R1. I use both abbreviated and unabbreviated addresses in both lowercase, uppercase, hex digits, showing that the allowed broader show command. So he's just demonstrating that you can do both abbreviated, unabbreviated, in both uppercase and lowercase for the hex digits as well. All right. Very good. All right, enabling IPv6 routing. While the configuration shows in the example, focus on the IPv6 configuration that also include an important but often overlooked step when configuring IPv6 on a Cisco router. IPv6 routing needs to be enabled. On Cisco routers, IPv4 routing is enabled by default, but IPv6 routing is not enabled by default. The solution takes one single command. So the super simple command, the IPv6 unicast routing command. Remember, that's in the global configuration mode. So the router configuration mode, you're going to hit it with the IPv6 space unicast hyphen, that's hyphen, right? Routing command. Okay. All right, and that will enable IPv6 routing. Okay. A router must enable IPv6 globally, so the IPv6 unicast routing command, and enable IPv6 on the interface's IPv6 address. So instead of IP address, so it would be IPv6 address, before the router will attempt to route IPv6 packets out the interface. If you omit the IPv6 unicast routing command, but configure the interface IPv6 address, the router will not route any received IPv6 packets, but the router will act as a IPv6 host. If you include the IPv6 unicast routing command, but omit all the interface IPv6 addresses, the router will be ready to route IPv6 packets, but have no interfaces that have IPv6 enabled. Effectively disable IPv6 routing. Cool. All right. Verifying the address configuration. IPv6 uses many show commands that mimic the syntax of the IPv4 show commands. For example, the show IPv6 interface brief command gives you interface IPv6 address info, but no prefix length, similar to how the show IPv6 show IP interface brief command. So just like if we remember when we were, when we discussed and when we covered IPv4 routing and stuff like that. So the show interface brief command. Remember, it does not show prefix length, subnet mask, whatever you want to call it. Neither does it. It's similar to. It's exact same thing it's doing with IPv6, where it's not showing the prefix length of the IPv6 addresses. So the show IPv6 interface command gives the details of the IPv6 interface settings, much like the show IP interface. So okay, cool. All right. The one notable difference is the most common command is the show interface command. Still lists all IPv4 addresses and masks, but it tells you nothing about IPv6. So the IPv6 interface address uses to see IPv6 interface addresses. Use the command use commands that begin with show IPv6. Okay. List shows a sample of R1s with the explanation. So the show IPv6 and then yada yada interface, whatever you want to look at. Very good. All right. Focus on the output of the two show IPv6 interface commands at the top with the list interface gigabit showing the output about the interface only. Note that the output lists the configurations of the IPv6 address and prefix length, as well as the IPv6 subnet. So the address here, which the router calculated based on the IPv6 address. The end of the example lists the output of the show IPv6 interface brief command, similar to the IPv4 focused show IP interface brief. Cool. This command lists the IPv6 addresses, but not the prefix length or prefixes. This command also lists all interfaces on the router, whether or not IPv6 is enabled on the interface. For example, in this case, the only interface on R1 that has IPv6 addresses is gig 00 and gig 000 as configured earlier in the example. Beyond the IPv6 addresses on the interface, the router also adds IPv6 connected routes to the IPv6 routing table off of each interface. Just as with IPv4, the router keeps these connected routes in the IPv6 routing table only when the interface is working on the up state. All right. But if the interface has an IPv6 unicast address configured, and the interface is working, the router adds the connected routes in the example. All right. So the show IPv6 routes. Remember we were discussing this kind of yesterday. We were going over this kind of yesterday. So and this is just showing the connected. So he's just looking at the connected routes, not all the routes. Okay. All right. Generating a unique interface ID using the modified EUI64. This is what I needed to go over. Okay. All right. IPv6 follows the similar general model as using IPv4 regarding which types of devices typically use static predefined addresses and which use dynamically learned addresses. For the example, routers inside a enterprise use static IPv4 addresses, while end users devices typically learn their IPv4 addresses using DHCP. With IPv6, routers also typically use static IPv4 addresses, while end users use DHCP for stateless address auto configuration. So the select to dynamically learn their IPv6 addresses. Even though engineers typically choose to use stable, predictable IPv6 interface addresses, iOS supports two different methods to configure a stable address. One method uses the IPv6 address command to define the entire 128-bit address, as shown in the example. The other method uses the IPv6 address command, but the command configures only the 64-bit IPv6 address for the interface and lets the router automatically generate a unique interface ID. The second method uses rules called modified EUI-64 extended unique identifier. EUI, extended unique identifier. All right. There is no other term or concept about the EUI-64 that you need to know for IPv6. The configurations that uses EUI-64 includes all keywords that to tell the router to use the IUI rule along with the 64 prefix length. The router then uses the EUI-64 to create the interface ID part of the address as follows. split the 60, insert the FFFF in between the two marking interfaces, ID. Oh boy. So we have the defined configuration, so obviously like what we'll do. And then we have the calculated by router using the EUI -64. And I'm guessing 64 represents the 64 bits in that address. That's left in that address range, I guess. All right. Kind of wrap my brain around all this. It's giving me a migraine. Check out these biceps. Ooh, yeah. I'm going bald, guys. I'm going bald. I look good, though. All right. Let's get back into it, guys. All right. You can find a video about the opinion website. You might have to take a look at that. Although this process might seem a bit convoluted, it works. Although with a little practice, you can look at the IPv6 address and quickly notice the FFEE in the middle of the interface ID, and then easily find the two halves of the corresponding interface MAC address. But you need to be ready to do the same math in the case to predict the IE format IPv6 address on the interface. For this example, ignore the final steps in the inverting the 7th bit. For the rest of the steps, just require that you move the pieces around to show the example. I see what this is doing. I see what this is doing. All right. I see what that's doing. Let's go over here, guys. I'll close that down. So here's our MAC address for gig 0, 0. So what that states is what it's going to do when we enable. So say we enable this on the IP6 address, the EUI 64. So what this will do, so say for instance we gave it the what was the what were we doing yesterday? Just a quick look. So we were giving everything the FD00 address. So say we did that again. That's in the last 64 bits, right? Yeah. Yeah. Alright, I get what that's doing. So say we did this, and we'll probably do it too. So say we did what we were doing yesterday, where we were giving everything the yeah. So say we did the FD 00 colon FD00 colon 1 colon 1 colon 1 colon 1 colon 1. All right. Yep, the FD0 colon colon 1. This address now would be because it's going to split this in half. So it'd be from there, it'd be 5254 colon 00 FF colon FE 122 Delta 8 Bravo, right? 1, 2, 3, 4, 5, 6, 7. We're missing a whole entire stinking quartet. Probably as a my default. Oh, that is my fault. I didn't add the other one. Rewrite that. So it'll be FD 00 colon 1 colon 1 colon 1. Right, and then it'd be colon 5254 colon 00 FF colon FE 12 colon 2 Delta 8 Bravo. So if we were to implement this on that router, and we'll do it too, I believe this would be our address that we would get. Let's make a connection. Let's test this out, guys. So that's how we would do it. Do this. FD00:1:1:/64. Alright. Now let's do a do show. IPv6 interface brief. Now let's take a look. Yep, exactly how I have it written. Perfect. So that, wait, oh, it's different. Where did that just come from? Why did it pick up a different address? So this is our, that's our link local. This is our, so that's, so what we just did, I mean, I don't know where it got the 50, because when I did the show Mac, well, the interface, when I looked at it, this is the MAC address for that. So I don't know where I got that other one from. It's okay. My boogie boogies. A boogie boogie. A boogie boogie. I'm just looking at OSPF again, guys. That's all I'm doing now. let's just read this real quick. So OSPF version 3 is a routing protocol for IPv4 and IPv6. Much of OSPF is the same as OSPF version 2, which is described in RC. Expand the commands to provide support for IPv6 routing larger areas. OSPF only supports IPv6 unicast families. But it seems so freaking different though. Yes, the command requires IPv6 routing protocol. Configure the address. Enable traditional IPv6 process 1 interface placed in area 0. Note that OSPF version 3 processes created automatically when OSPF is enabled in the interface. If the router ID has not been created first, the router may use a warning, no router ID, stating that the process cannot pick a router ID. It will tell you to do IPv. IPv6 OSPF area process 1 area 0. OSPF version 3 is so much different. It's saying it's the same, but it's so different. My book is really not helping me. Exit. Router. SPF 3. Let's do. Run the configuration real quick. IPv6, yes. All right, so we have interface. Oh, you know what I didn't do? I didn't turn it on. It's still shut down, actually. Goofball. All right, yep, okay. So router. Link is up now. Over here to this router now. All right, let's go. Router. F. 3. Process 1. Router ID. IPv6 routing. Two interface gig 0-0. Then we're going to do the IPv6 address the 00101 4. Okay. Then we're going to hit it with the V6 OSPF process 0. Still didn't make a neighborship. That's all I'm trying to do. So let's do this then. Let's go back to router F3 process 1. Let's give it the range. Area 0 range. Okay. Have to. Interface, click through. You don't have to do that to make an adjacency. I'm still not making an adjacency. WSPF version 3 eludes me right now. Ah, we made an adjacency. Alright, so we actually made an adjacency. Finally. We did that. Ping successfully, so we're good there. All right. Now what I want to do is this. So let's move into interface. I'll have to do this on each interface, right? Interface gig 1, IPv6 address. I'm going to go with the D0 1 1 1. We'll go with 2. Go with 10. Colon. Not 10. 10 is not pretty number. We'll go with alpha. Colon. / 64. Shot. 6. OSPF. OSPF. Process 1. Area 0. Okay. This one, interface gig 0F1, IPv6 address. We'll go with the FD00 :1 :1 B 1:/64. Shut. All right, and then we're gonna give this the OSPF process 1 area 0. All right, now let's do show routes. Yes, OSPF is working perfectly. All right. Show IPv6 route. Yes. All right. We're good. We're good. All right. All right. So we got OSPF on. So let's do a do right on these real quick, guys. We're doing pretty good. Alright, so let's exit. Let's do IPv6 DHCP. Cool. One. All right. So say addresses, and this is the FD00:1:1:IA:/64 network. D00:1:1/64. Okay. Might be all we have to do. Let's give it a shot. Let's hook this host up to this router now. Let's boot up this host. What's up, Gamer Golf? Good evening. Haha. It's going pretty good. It's going pretty good. We finally figured out OSVF version 3. Well, I don't know if we completely figured it out, but we got it to work at least. And so I'm also implementing, I'm seeing if I did it correctly, with IPv6, DHCP, what is it, version 3? Is that what? Oh, no, DHCP version 6. So we're hoping I did it correctly to see if we got dynamically addressed a IPv6 address on this host here. So let's take a look. Did we? We did. We did. We got an address. Oh, sweet, dude. I'm like super pumped up right now. Woo! All right. Now let's see if I can ping. Let's do a do show V6 interface brief. Let's see if we can ping this address. So this would be this on router 2. Let's just see if we can ping the other side. So this side of router 2 off of this host right here. So let's do a do ping. That one. Yes, we did it, dude. Oh, super pumped up right now. Woo, 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 woo. Success, man. We got this. Oh, I'm super pumped up. Woo, woo, woo. All right, so a couple of things we just did, everybody. So we implemented OSPF version 3. All right, so we made an adjacency because you remember, so Gamer Golf. Remember yesterday I was like biffing it so hard with statically addressing everything, and it was just coming up. Everything was just messing up so bad. Oh, yes. I'll fix that right now, my friend. Yes. Thank you for saying something. Bloop. All right, there we go. And if you much better. All right. If you need me to zoom in more, just tell me, and I'll zoom in more too. FYI. That's just I just threw this one. I threw this one together the other day because that's exact. Because I think it was you too who asked me to zoom. It was you or a couple other people asked me to make a zoom in scene. So if you need me to zoom in more, just ask me and I'll definitely zoom in more. All right. So we're definitely cooking with gasolina. So let's come over to R2 now. So we're over in R2 and we're gonna do the same thing. Let me just let me write this configuration real quick. And yes, that was real last night with the static assignment. R1 could not ping R3 through R2 and could have done drops of packets. Yeah, I don't know what I was like. I was biffing it hardcore, biffing it super hardcore yesterday. And it was weird too, because remember we got those weird pings where we would have one successful ping, but then two successful unsuccessful pings, and then we would have another successful ping. I couldn't understand what it was doing. It was breaking my brain. So let's exit. Let's go into IPv6 DHCP pool. We're gonna call this net net 2. All right, so address prefix, and this is the FD00 FD00 :1 Bravo /64 net. All right. Let's make a connection. Let's boot up this host right here. All right. And what you're seeing right here, this little so what I was going over just before you had joined Gamer, we were going over the IPv6 address prefix. So like, well, not prefix. So the your I guess like your unique local address or your global. Yeah, so it'll be your unique local address or your global address, but then hitting it with the what's my favorite flavor? It's Ubuntu. I love Ubuntu. That's my favorite flavor of Linux. I love Ubuntu. Ubuntu's great. I kind of started off with Ubuntu, and I just find it how they have the way. I just find it a little bit easier to get around everything in Ubuntu than say Fedora and stuff like that. I mean, there's nothing wrong with Fedora. It's just like how to like set up like just being able to like, I mean, I already know how to do it, but just you have to figure out like just being able to get to become, to set up administrative permissions on like a Fedora or a Red, because that's like Red Hat Enterprise Linux. You know what I'm saying? There's a little bit more of a process instead of just Ubuntu where you can just assign. You know what I'm saying? I mean, I guess you could do it on both. For some reason, I just like Ubuntu a little bit better for some reason. But I do recognize and understand though that when it comes to like developing like actual, well, I can't say that because a lot of things are created on Ubuntu too. You know what I'm saying? I see a lot of applications being created on top of Ubuntu. So I can't just say Red Hat Enterprise Linux is what something I have to focus on, but in the bigger scheme of the real, like how, like we'll say like AWS and all that is, I would have to be, I'm going to have to take and spend a lot of more time on flavors like Fedora and stuff like that just to become more familiar with Red Hat Enterprise Linux, Um, um, but again, my favorite flavor of Linux is definitely Ubuntu, hands down Ubuntu. I love my little tux, my little penguin. What's your favorite flavor? And don't say Kali Linux, because that's Ubuntu. Yes. All right. Cool. So we got an address. Very good. Very good. All right. Now let's ping. Let's copy this. I knew you were gonna say Kali Linux. How did I know you were gonna say Kali Linux? It is Ubuntu. What's poppin', Maxwell says.
Talking to your friend Muffin.
No, I'm talking to Gamer. Gamer Golf.
Gamer Golf?
Alright, let's ping. Let's ping.
Pretty printer still hot?
Yeah, it is 90%. You are correct. You are exactly correct. It is 90% Debian. But how's this? Like, I guess there's just more support with Ubuntu than I would say, like, because so I like, I'm not afraid to download images and stuff like that. Let's just see if we can. All right, yes, we can ping host one. Host one can ping host two. Okay, so we're cooking with gasoline right now, guys. I'm super pumped up. Yeah. All right. Cool. So you know what I'm saying. You know what I'm saying. When it comes to like, so I have my in-laws, and they gave me a PC that that my brother-in-law, he's young, a lot younger than I. He destroyed their PC. I don't know what he was doing, probably looking up porn and whatever else. But he infected this thing to high heck. So I'm actually planning on wiping that PC. I mean, I told them they can just buy another PC. I mean, it's cheap to buy, basic PCs these days. But as a I guess thing I wanted to do was I wanted to completely clean it out, wipe it completely down to nothing, bare metal, and then I wanted to upload an Ubuntu GUI image to it. So with the desktop, the Ubuntu desktop image that has all the bells and whistles and everything on it, and I wanted to see if I can get them to be able to use it without no issues, like without them questioning the fact that it isn't Windows. You know what I'm saying? Because I wanted to see if I could get somebody who doesn't really know much about operating systems and whatnot to use a operating system that is not Windows, and have them actually be able to use it like they were using something like Windows. You know what I'm saying? Because of what the Ubuntu desktop has. It has, you know what I'm saying? It has even all those cool little programs that are comparable to like Word, Excel, and stuff like that, all for free. I mean, it's all dumped on there for free. And then everything else just works beautifully. It just works awesome on there. So that was an that's an experiment that I'm going to be doing, just to see if I can quote unquote kind of trick them to believing that they're using a different version of Windows, but it's actually Ubuntu desktop. So that's something that we'll be doing soon too, as a stream that I was kind of planning. So, but yeah, all right. I'm actually kind of pumped up right now, guys. So we just have a let me just make sure I write these. You right. Let me get over to Git real quick. I just wanted to just jump over to Git because I didn't actually bring up Git earlier, so I can dump this configuration into there. All right, so let's get back to now that we actually got everything up and running, guys, and I'm super pumped up right now. Super pumped up. Yeah, so we've made some big steps right now. Let me just change this up real quick. Bloop. All right. Seamlessly and effortlessly. All right. Clear the screen. All right. So where we kind of left off, and where this address that I was using came from. So this one, let me just see. All right, get it right there. Okay, perfect. So what I was going with this address here, guys, is we were talking about the EUI-64. If you were to hit the erase button, could you get everything back up and running like it is now again? So on that topology, yeah, I actually that is a good challenge, my friend. Let's do this then. I have just been challenged, and I accept. I accept your challenge, sir. All right, let's do it then. So, let's do this then. I just that makes me feel good. All right, so let's add so you're ahead of me in that game for sure. Let's add another router. I have been challenged. So let's add another router. And what we'll do is we'll add another we're gonna add another let's add another host too as well. Let's grab another host. So this will be host 3. All right, and then what we'll do, let's do this. Actually, let's wait on that connection. Actually, we can make that connection now. Let's go to this. All right. Oh, dude, IPv6 is giving me such a headache because it's like, it's it's like, yes, fundamentally it's similar to IPv4, but there are so many, like, what I'm finding is there's so many nuances that are just totally, that are different. Like just setting up OSPF, like, it took me a while to like think about how like the process worked on it and how it should be. Um, and what I'm finding is there's no like, so on IPv4 you can set up like you can set up OSPF to like gobble up a range. You can just like set up OSPF to like on like a global command to say, okay, I want if I want this network inside of my area. OSPF version 3 though seems like you have to do it per interface, and then what we're gonna find out though is if um, because there was one command that I don't think I needed to do, and that was the OSPF neighbor address for the link local. I don't think I have to do that, but we're gonna find it. We'll actually find out here with this router 3. So this challenge that you've dawned upon me, my friend, might actually help me learn something more too about OSPF version 3. Okay, so let's do this. Interface gig, and that was gig 2. Let's say IPv6 address, and again we're going to hit it with the EUI just to maintain what we've been studying. So we're going to go with the FD 00 1:1:1. We'll hit this with the 3. Yes, we'll hit this with the 3://64 EUI 64, and we'll hit it with the no shut. All right, and then we're going to say IPv. IPv OSPF process 1 area 0. All right, and that should be it there. Now let's go over to router 3. We're gonna hit this with the no. We don't want the initial. I said no. You crazy thing. Give that a minute to do its boot. Right, I need to go back to my Zoom so you guys can see it. Zoom. Oh, we're in there. Oh, we're in there like a swimwear. Oh, you gotta love these tracebacks. Gotta love these tracebacks. These tracebacks happen once in a while on this. I don't know if it's. I mean, you can see my CPU usage. It's not even that. It's not. I mean, I'm only at 33% here. I give Cisco Modern Lab six CPUs, 6 virtual CPUs, and I'm also giving my server 6 CPUs. So I mean, I'm giving it exactly what it needs. What is your stream buddy's last Minecraft one? So while we're waiting for router to boot, what is your stream buddy's latest Minecraft project? My stream buddy's last Minecraft project. I'm trying to think. Who's my stream buddy?
Me.
You're my stream buddy?
Hello.
Hello. These guys play crazy Fortnite.
Fortnite's the best. I'm your stream buddy.
Oh, yeah, my 2 sons. They play crazy Fortnite like maniacs. They're addicted. They love. So my other son. So I have 3 kids all together. So I got.
Nick used to play Fortnite.
So there's the Maniac Max, the Mad Max right here. Say hi.
I can crack 90.
He can crack 90s all day long.
And no scope.
No scopes them. He no scopes them noobs.
And did you know he's the first one? He's OG strong because he
Season 1, huh? Maniac Max. He's a maniac, all right. So yeah, him and the other one, my other one, Joe, my Joe Jr. He plays Minecraft. Yeah, you play Fortnite 24/7. Sure you do. Him and his cousin, they love modding Minecraft. They put in they had gun mods in Minecraft the other day. I was like, what are you guys doing? All right.
Gonna do the no sweat.
No sweat. IPv6. What are you dancing over there?
Yes, doing floss.
You doing the flossy flossy?
Orange justice.
Orange justice. Do the orange justice. All right. So, router OS PF version 3. All right. Process ID 1. Process ID 1. Okay. This is where I messed up before. Now we're going to give this the router ID 3.3.3.3. All right. Now let's move into, interface gig 00. All right. IPv6 address, and that's the FD 00.101.0.3:/64. Give this the no shut command here. Right. Dude, I've been trying to get them into coding because I keep telling them, like, listen, this is like the they do coding, they do like the little kid coding in school now. Because I've been, ever since the pandemic, I've kept all my kids home since last year. So they've been homeschooled for the last 2 years now. And obviously they're doing the virtual learning still. And they do that little kid coding and stuff like that, which is really neat. But I've been trying to get all of them. IPv6 OSPF process ID area 0. Now let's see if we make. Yes, we did it. So we don't need to add that other command in there to enable OSPF on IPv6. All right. Thank you, Gamer Golf, for hitting me up with this challenge. Because, all right, so we just made an adjacency. All right, so we just made an adjacency with router R1 here. All right. So if we do a do show IPv6 route, all right. Yes, we have OSPF learned IPv6 routes in our routing table now. Perfect. Perfect. All right. So that right there. So just giving the IPv once you give it, you have to obviously give it a router ID or obviously I don't know if you can use the loopback address with OSPF version 3. I don't know yet, but we'll figure that out. But either way, so we went into the global configuration in the global configuration mode. Thank you. And thank you for this challenge, because this just helped me figure out again what I was doing wrong with OSPF version 3. Okay, so in global configuration mode, hit it with the router OSPF version 3 process ID, whatever you want to. But then in there, then you assign it the router ID number. But then in interface configuration mode, whatever interface that you are enabling, whatever area, okay, you just hit it with the IPv6 OSPF whatever process ID again, and then area, whatever area 1. So we're just using the backbone area 0 here, okay? And then boom, we made our adjacency to our other router, and then our OSPF, all right, our routing tables are being dynamically learned for the rest of the network that we're connected to. I'm freaking stoked right now. Okay, all right, so we got that. Now, let's put the do right, okay? And now let's go into the other one, and we're gonna do the same thing we'll set up IPv6 DHCP server on router R3 too as well. Okay, so let's do this. Let's interface gig 01, right? Right. Because that's what we're gonna hook this PC up to. Yep, gig 1. All right, let's do this again. So let's hit this with the IPv6 address, and we're gonna hit it with the FD00:1:1, and we're gonna give this the Charlie. We're gonna give that the Charlie network, Charlie subnet, whatever. I'm just going ABC. That's all I'm doing. Keeping it easy. Oh wait. Oh. There you go. All right. Cool. We'll hit it with the node shut. All right. And then let's hit it with the IPv. All right, IPv6, OSPF, process ID area 02 as well. All right. Now let's exit. Now let's go IPv6, DHCP, pool. We're gonna call you net 3. All right, address prefix. All right, and that'll be the FD 00:1:1:Charlie:/64. Okay. Now, when we boot up this host here, let's boot up this host.
You want to do some Fortnite streaming tomorrow?
Hmm.
Want to do some Fortnite streaming tomorrow?
Listen, buddy.
Because it's been a long time.
Yes.
You've been
We must study, Maxwell. We must learn everything.
off for 7 days.
You've been off Fortnite for 7 days.
Yes. What? We need to play more Fortnite. Fortnite's a popular game. Before Among Us came out.
Before Among Us came out.
So
Sweet. All right, so we got our address now. Let's copy that. Copy. Let's come over to host 1 now,
Fortnite.
and let's ping that.
Play Fortnite.
Oh. All right, so it looks like we got an issue. Let's diagnose this issue real quick. Show IP routes. No, not routes. Show IPv6 routes. All right, so I got the Charlie network in there. What the heck is going on? Oh, I see. I didn't copy the address all the way. Scooby Dooby Doo. There we go. All right. Woo! I just didn't copy the address all the way. Like, what is going on? All right. So there we go. Challenge accepted and challenge. There we go. So we've been able to successfully, and let me just go to the thingy so you can see here. So from host 1 here, we can now ping host 3. All right. And host 3 is located at I know you, yeah, so go back to the Zoom. Pew. So at this highlighted address right here, this is host 3's address, okay? All right, so from host 1 here, as you can tell, we can ping that address successfully. So we're able to route between, yeah, so we've successfully set up OSPF and been able to route between the networks. Yes, okay, let's do that then. So let's go over to host 2. Very good. Ping. A paste. And there we go. Beautiful, baby. So there we go. So from host 2, which is in the Bravo network. Thank you, Gamer Golf. So from host 2, which is in the Bravo network, it's pretty much, and we can do a trace route on that too. So let's do a trace route. Paste. And we can see the route that it's taken. Obviously, we already know the route it's going to take. But just for completeness, so you guys can see what it's going. So it's obviously going through Bravo. It's going over now to from Bravo, where are we at? To router. So R1's interface. So that's the 1. All right. To 3. So that's the 3. All right. And then to Charlie, which is host 3 right here. Okay. All right. Whoop, 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 whoop. OSPF 6. We are kicking your butt, OSPF 6. All right. Cool. Let's write this configuration real quick. Let's make sure we save it. All right. Make sure we save R2s. I think I already did, but just for completeness purposes, I just want to make sure saving these configurations, because I'm gonna upload this to right to Git afterwards too, guys. So again, if anybody's interested in taking a look at that, most definitely you can. All right. So let me start the process of actually writing these configurations, because this ended up taking a while yesterday when I did this. So let's fetch those configurations while we continue reading on here. All right, and Gamer Golf again, man. Thank you very much. That was an awesome. That helped me understand the process better, actually, when we just did that again. So shout out to you, man. That was awesome. Good looking out. All right. Where we at? So yeah. So just like when we were giving it the EUI 64 command, what that is doing and what that was doing and what it was elaborating to was it takes the MAC address. So the interface. Whatever your network interface card off of that interface is, all right, it takes that MAC address, okay, it splits it right down in half, okay, and then it inserts into the 88th. It's the 88th bit. It starts at the 88th bit, okay. That was something that I kind of figured out. It starts at the 88th bit where it inserts the FF:FE. So starting at the 88th bit, so right here is the 88th bit. It inserts that FF:FE into your address, okay? but what it's doing is it's allowing the interfaces to make their own dynamic address while using their own MAC addresses, so the interface MAC addresses. Okay, so it's just a process of saying, okay, I don't want to. It's just making the process of creating a IPv6 address simpler. That's all that this command is doing. So the IUE -64 command that's followed. All right, and it's going to show it down here when we get down there. But I just want you guys to see this example right here. Okay, so one, there's the MAC address off of that interface. It splits into halfies. Okay, it inserts the FE, the FFFE. All right, and then it leaves you with the interface ID. Okay, the interface ID, just like in IPv4 when we would talk about like host, the host address, whatever. On IPv6, it's just calling it the interface ID. Okay, so let's just make sure that so we fetch that. That looks good. All right, that looks good. We go to R2 now. Let's fetch that. All right. Both the examples follow the same process. Each starts with the MAC address, breaking it into two halves. Step 2 then takes it, inserts the FFFE in the middle, and the fourth steps inserts the colon every fourth hex digit, keeping the IPv6, keeping with the IPv6 convention. While the example in the figure shows most of the steps, they omit the final step. The final step requires that you convert the first bits, the first two hex digits from the hex binary, invert the seventh of the eighth bit, and convert bits back to hex. Inverting a bit means that if the bit is a 0, make it a 1. If it is a 1, make it a 0. Most of the times with IPv6 addresses, the original bit will be a 0 and will be inverted into a 1. Very good. Okay. For example, in the figure, completes the two steps for the from the figure, focusing on only the first two steps, the hex digits. The next example shows each pair of the hex digits. Step 1, the binary equivalent. Step 3 shows a copy of those 8 bits, except the 7th bit is inverted. This example, the example on the left inverts from 0 to 1, and the example on the right inverts 1 to 0. Finally, the 2 bits are converted back to hex in step 4. So a lot of converting back and forth and having fun with hex biddies. The hex biddies. Let's make sure that one's done. All right, let's go to host .b here. Let's fetch there. A configuration. All right. If you don't remember how to do hex binary conversion, takes a few minutes. Yep. All right. So that's just talking about the appendix. For those who prefer to do decimal shortcuts with little memorization, you can do the bit flip math doing any hex binary conversion. First, note the process to invert the 7th bit when working with hexadecimal IPv6 addresses. Flip the third of the 4th bit in a single hex digit with only 16 single hex digits. You can memorize what each hex digit becomes if it is the 3rd bit is inverted, and you can easily memorize those values with a visual process. Woo! I love me some binary IPv6 hexadecimal. It makes my brain hurt stuff. If you want to try to memorize these values, it helps to walk through the following process a few times. So grab a piece of scratch paper. I'm going to need more than scratch paper for this. Then write the 16 single hex digits as shown on the left. On the left of the left side. That's it, and write them in an 8th row with two numbers each with spaces as directed to figure. If I had to throw myself out a window. That's next to start the top of the list and draw an arrow lines between the two numbers in the same column on the left. Then move down the left side of the column, connecting the next two digits, the fourth and the sixth, with arrows. Then the eighth and the A, then C and E, and repeat the process on the. Woo! My brain hurts, man. My brain hurts. All right, what is he doing? Just trying to figure out what he's trying to get at here. Melts my brain. I'm trying to even. This whole thing just eluded me. I can usually catch on to things like this, but honestly, this just eluded me. We're gonna have to keep moving on. We'll have to go back to that afterwards because that whole thing just eluded me. The figure you drew shows the hex digits, which when you invert them to a bit, convert to the other. That is 0 converts to a 2. 1 converts to a 3. 6, 4. All right, wait. The figure you drew shows the hex digit when you invert the third bit, convert to the other. You can avoid doing binary hex conversions. Use the approach makes it more comfortable. Oh, I think I know. I think I understand what this is getting at. Okay. X1. Wait. Where is he going with this conversion? Here's the best way to get comfortable with forming these interface IDs is to calculate some of yourself. This shows a practice with the IPv6 64-bit prefix, the first column, MAC address, the second column. Your job is to calculate the full unabbreviated. Yeah, I mean, we can do this easily. Using the rules, the answers would be at the end. So let's do this real quick then. Let's do these. Let me pull up Notepad real quick, and then that way we can save these. So we'll go. And then we'll say the Mackies are on this side. All right, and then this will equal. All right, 2001 colon. Let's put on caps lock so we can keep it same format. DB8. The unabbreviated. So they want the full. So do I have to put all these crazy zeros in there? Let's do it then. 1, 2. Three, 1, 3, 1, and then the MAC addressee. So remember, we're gonna split it in half. So we're gonna do 0013 colon alpha Bravo FF colon FE alpha Bravo and then colon 101. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So that'd be 1. All right. Copy. Paste. All right, so 2001 colon Delta Bravo. Oh, it's gonna be the same thing. No, it's not. A couple of them are gonna be the same thing, so we can almost do this then. Whatever. We'll just continue. Continue on here. Delta 0 Delta Bravo 8 colon 001 colon 001 colon alpha alpha 13 alpha alpha 13 colon alpha Bravo FF colon FE alpha Bravo colon. Wait, did I biff something again? Yeah, no, it's different. Yeah. Yeah. Any fun, exciting plans for the weekend? Yeah, I'm working. So I got tonight off, and I got tomorrow night off. I'm hoping I got a paper due for my humanities class, so I got that I got to do. I got to start that tonight because I haven't started it yet because that's due on Sunday night. Well, Monday morning, but Sunday night, either way. So I got to get that done. And the reason why I need to do it tonight and tomorrow is because obviously I'll be working the next 2 nights. Well, I'll be working the weekend. What stinks is, again, me working this overnight shift. I don't really get to really spend time with the wife and the kiddos during the day, which stinks because I need to make sure that I get some sleep. I'm hoping I'm gonna be quitting this job though, but I'm gonna be I'm going through the like I think we talked about it yesterday. Hopefully I finished the drug screen and all that for the pre-employment step for the forklifting job, and that's gonna be part-time. And that's what I'm hoping for, because honestly, with everything, with doing school and all this other thing, like I can't, as much as I want to be able to work full time and be able to do that, I'm not able to put as much attention onto the things that I really want to be putting attention on. Like I need to be focusing on updating my resume constantly. And even that takes time. Updating my resume, making sure that it looks good, and actually applying for jobs because I mean, you know how it is. Like in trying to get the right job, like you need to be continuously applying for jobs and jobs and jobs and jobs. You can't just settle for what you got right now. This isn't what you want. And obviously, I don't want to just be doing these random bogus jobs. I want to get into the IT field, so that takes me. My LinkedIn profile is it. I actually have a link to it. So if you go to my about on my Twitch about tab, if you go to that, you can actually there's a link to it if you want to check it out. Gamer Golf. If you want to make a connection, go ahead and make a connection with me, and I'll connect with you. And maybe you can give me some advice on it. I have done a lot of work on it initially, and again, with being so tied up, like that's one thing too that I need to continue to update, continue to make better. I was going with the content creator type thing with networking and all that stuff. But yeah, again, I have to, and a lot of it is my resume too. Like if you make a connection on me, you'll be able to see my resume. And I think I went overboard with my resume. I think I made it look because I made it too graphically nice. I think. I can't even remember my LinkedIn password anymore. Right? When you don't use something for a while, you tend to forget all the. That's one thing too. Like I had one years ago, and I had to like reset everything once I lost my freaking operational manager job. It's like I needed like I that was one thing. Once I lost that job, it was like, oh boy, time to get my poop together, and I had to get scramble to update resumes and all that stuff. So yeah. Again, like I said, I think one thing that's holding me back a lot is my stinking resume. I made it again. A couple people that have critiqued it or looked at it has said, Joe, like, listen, it looks too much like a web page. You made it too graphically. Yeah, it's pretty and it's really wordy, but that's the problem with it. It's too wordy. It's too pretty. It's being overlooked by like their some big companies have like like automation tools that will look at your resume before even a human being sees it these days, and if it doesn't fit certain formats, that it just ejects it, and I think that's what's been happening to mine, you know. All right, I'm not gonna. Well, let's do one more. Let's do one more for the old soul here, and then we'll move on. We'll continue on with our reading. All right, so 2001 Space Odyssey, Delta Bravo 0, Delta Bravo 8, colon 1, colon 001. This is going to be 000 Charlie. B E F F colon F E F E where am I beefing this? Where did I mess up? Oh, EF. Yeah. FE, EF. I'm like confusing myself all of a sudden. CAF. There we go. All right, so let's just do those three for now. I don't want to waste too much time on that, and then we'll see if we're right at the final end. All right. All right. Actually, let's go see if we're right now. I'm curious now. So 2001. So it abbreviated, even though it said unabbreviated, it still abbreviated the stinking addresses. And we did it wrong. And I think I know why. And it goes back to what this was saying. And it goes back. Now I see why. I get it. Oh, yeah. All the way back here. All right. I get it. All right. And that's why these addresses had changed on these interfaces. And I was wondering why that happened. All right. So what that is stating, that what this is, oh, I didn't want to do that. Stupid. What that is stating. So what this is going over, guys, is when we do this, when we use the IPv6 address, give it the prefix of our oh geez, that just like shut everything down, didn't it? Did. When we give it the so the IPv6 address, and then our prefix, and then the EUI command -64. Obviously, it's splitting this our MAC address in half. Okay, all right. What I did not, I guess, and then this was what this was getting at. Okay, so when we get that address, okay, this bit, so this bit right here, okay, it is always, let me see, which bit was it? No, it's this bit. Yes, it's this bit. So it is it was saying it. Which bit was it? Copy the 8th bit. So the 8th bit. So the 8th bit. So yes, right here. So it'd be the 8th bit. So 1, 2, 3, 4. Yeah. Actually, it's this one. It's this one, all of them. This is the 8th bit. Yeah. Yeah. Even though this picture shows it like here, it's actually this bit. This is the bit right here, guys. So it's this bit right here. So this, again, this would convert to a 2. Yeah, we'll just say that would, let's put a 0 back there and we'll go with the address. So this would convert to a 2. Following this example here, this would convert to a 2, and then 8, and then 2. All right, and then if we go back down, all right, I get it. I kind of understand it now. All right, again, yeah. So again, so there we are. So on that bit right there, so the 8th bit. So the 8th bit. So the 8th bit. So 4, 8. So the 4th. So this is 4th, and then this is the 8th bit. Okay. Again, remember, and in IPv6, the bits are 4 bits each. So in the 8th bit, so 4, 8. Okay. All right. Again, I know it's slightly confusing. What you have to, there's that conversion table, and that conversion table worked, and then that's what that was demonstrating right there. Okay. So you can see how the 0 turns into a 2, the 8 turns into an 8, and just converting it over. Okay. That's all that. Okay, so that was good. That was good that we did that. So we have a little bit. We dawned a little bit of light on what that was actually going, because this kind of eluded me at first. All right. So good deal that we actually went back in and took a look at what we just did. All right, we got all of that fetched now. Let's do this. That's not what I wanted to do. Here. Let's download the lab. Go to Git real quick. Go to file. IPv6. Ooh, I still got caps lock. IPv6 OSPF version 3 and DHCP DHCP version, that's version 6. All right, and then add additional simple lab with initial IPv6 implementation. Again, if you go over to Cisco Modern Lab, you guys can see that new commit that I just made in GitHub. Okay, so there you go. That's there now. Very good. All right, let's continue on here. All right, we covered that. The configuration of the router interface to use the IUE 64 format uses the IPv address slash address slash prefix on, and then the IUE, the EUI hyphen 64 interface subcommand. The EUI hyphen 64 keyword tells the router to find the interface's MAC address and to do the IUE 64 conversion map to find the interface ID. And that is what I did in that lab too, guys. So when you guys take a look at that lab, you'll see that that's what I used to configure the IPv6 MAC addresses in that lab. Okay. All right. Shows the example shows a revised configuration on R1 as compared to the earlier. In the example, in the case of R1, uses the EUI-64 format of their IPv6 address, configuring R1's IPv6 interface using the UIE-64. Again, this is exactly what we did. He over here though, he is changing the obviously the MAC addressee to it. So let me see. Gig 00. Yeah, this one makes sense. But what is he doing on gig 00? Well, I don't know the MAC address that gig 000 interface. All right. The example uses the Ethernet, only Ethernet, all of which has a universal MAC address to create the EUI-64 interface ID. However, in this case, the configuration includes the MAC address command under R1's gigabit 0, which causes the iOS to use the configured MAC address instead of the universal burnt-in MAC address. Interface gig 00's default to use its universal MAC address. Follow the math. Yes. All right. So this is on Be aware that the interfaces that do not have a MAC address, like a serial interface, the router uses the MAC address, lowest number router interface that does not have a MAC. All right, when you use the UEI, the EUI 60-64, the address values in the IPv6 address command should be a prefix, not the full 128 bit IPv6 address. However, if you mistakenly type the full address and still use the EUI -64 keyword, the IOX accepts the commands and converts the address to the matching prefix before putting the command into the running configuration. For example, iOS converts IPv6 address 2000:1:1:1/64 EUI -64 to IPv6 address, yada yada. So it's just removing that trailing one at the end. Okay. Dynamic unicast address configurations. Okay. So in most cases, network engineer will configure the IPv6 address of the router's interface so that the router's address does not change until the engineer changes the router configuration. However, routers can be configured to use dynamically learned IPv6 addresses. These can be useful for routers routing connections to the internet through some type of internet access technology like DSL. All right. Cisco routers support two ways for the router's interface to dynamically learn IPv6 addresses to use. Stateful DHCP, and stateless auto configuration, so the slack configuration. Okay. Both use the familiar IPv6 address command. Of course, neither options configure the actual IPv6 address. Instead, the command config a keyword that tells the router which method to learn its IPv6 address. Each example shows some configuration with one interface using DHCP and one using Slack. So I'm guessing the DHCP one is the IP address DHCP, just like we would do on IPv4 when we're allowing a DHCP server to dynamically allocate us an address. And then if we were to use the Slack, we would use the IP address auto config. All right. Special addresses used by routers. IPv6 configurations on a routers begin with a simple step discussed in the first part of this chapter. After you configure the IP unicast routing command, global configuration command, to enable the functions of the IPv6 router, excuse me. The addition of the unicast IPv6 address on the interfaces cause the router to do the following. Gives the interface a unicast IPv6 address, enable the routing of IPv6 packets in and out of the interface, defines IPv6 prefix that exists off the interface, tells the router to add IPv6 connected routes to the prefix and to the IPv6 router table when interface is in the up state. Okay. Note, in fact, if you pause and look at the list again, see changes where yep. All right. When all IPv6 features in the list work much similar like IPv4, IPv6 also has a number of additional functions not seen by IPv4. Often, these additional functions use IPv6, mainly of which are multicast addresses. This major section of this chapter examines the additional IPv6 address seen on a router with a brief description of how they are used. Okay, so let's take a look. We have linked local addresses. IPv6 uses linked local addresses as a special kind of unicast IPv6 address. These addresses are not used in formal IPv6 packet flow. They contain data for applications. Instead, these addresses are used by some overhead protocol for routing. This next major topic first looks at how IPv6 uses link local addresses, and then how routers create link to link addresses. Okay. Link local address concept. IPv6 defines rules so that packets sent by to any link local address should not be forwarded by any router to another subnet. As a result, several IPv6 protocols make use of the link local addresses when protocol messages need to stay within the local area LAN. For example, Neighborhood Discovery Protocol, which replaces the function of IPv4's ARP, uses link local addresses. Routers also use link local addresses as the next hop IP address in the IPv6 table, as shown in the figure. IPv6 hosts also use default routes, default gateways concept like IPv4, but instead of the router address being in the same subnet, host referred to the router link local address. The show IPv6 routes command lists the link local addresses of the neighboring routers rather than the global unicast, unique local unicast. Okay. Very good. All right. Let me stand up real quick, guys. Wow, I need to stretch my legs. We'll get over to the whiteboard. Let's go whiteboarding. Might change my scene. Let's change the scene, baby. All right. All right, where we're at. So link local, next hop. Hey, Joe. Come here real quick. I have my son make me some more coffee real quick. Joey. Got my boy on a coffee delivery. All right. So, following some key facts about the link local addresses. Okay. All right. Unicast, not multicast. Unicast, not multicast. Remember. All right. So, link local addresses represent a single host in packets sent to a link local address. Address should be processed by only the IPv6 host. Forwarding scope is the link local.
Just making you coffee.
Thank you, buddy.
No.
What are you, hot or something?
Yes.
All right.
Let's pretend nobody saw that. Because YouTube is not supposed to see that.
Forwarding scope in the is the link local only. Packets sent to the link local addresses.
On YouTube,
You need to.
just edit that.
Okay, I'll edit that out. Yeah, I'm live streaming.
You're going 12.
Yeah, it's 12. So put 12 and then press the strong button too. Okay. Yeah. Look out. So we're going over IPv6 and stuff like that. I made a lab, so we're using bigger addresses now, and it's a little bit different than how we were using the IPv4 addresses. So these kind of addresses are like, I guess I would say like they cover a bigger range, so you can add more hosts to it. I mean, generally inside of like a house, you wouldn't generally have it,
Oh, okay.
but yeah, he's not very interested. All right. automatically generating every IPv6 host interface and router interface can create its own link local addresses automatically. Solving some initial programs for hosts before they learn a dynamically learned global unicast address. Common uses: link local addresses are used for some overhead protocols that stay local to one subnet and as the next hop address for IPv6 routes. All right, creating link local addresses on routers. IPv6 hosts and routers can calculate their own link local addresses for each interface using some basic rules.
Why do you like coffee black?
Does it taste like coffee?
Anybody in the stream?
Yeah, I got a couple of people. Say hi.
Hello.
Only way to drink coffee.
Wait. Say if you drink, and you like that.
The camera's right there.
Oh. Does any of you drink a gross black coffee?
It's not gross. It's
Yes,
gross.
it is. I like regular coffee, then black coffee.
Only sissies put cream in their coffee.
I put sugar too.
Exactly. You're an extra sissy.
No, I'm not.
We're having a discussion about black coffee versus creamer in your coffee. My caffeine comes straight from Pepsi. That's what he said. He said
Wait, can I see?
it comes straight from Pepsi.
Oh my god. No, it doesn't. It comes from milk. And other different.
There's no caffeine in milk, you psycho baby.
No, you're psycho baby.
You're a psycho baby. Get out of here. Get out of here. You're mean. You smell like doo doo.
You smell like doo-doo.
You're a doo doo head. All right. Calculating link local addresses on a router. IPv6 hosts and routers can calculate their own link local addresses for each interface using some basic rules. First, all link local addresses start with some prefix as shown on the left side. By definition, the first 10 bits must match the prefix FE80 ::10, meaning that the first 3 hex digits will be FE8, FE9, FE obviously 10, which is represented by FEA, or FEB, which is represented by 11. All right. However, the following RFC, when the following the RFC, the next 54 bits should be binary zeros, so that the link local address should always start with FE80:00 for the next 54 bits as the first unabbreviated quartets there. Okay. I would never drink anything else ever again. Caffeinated chocolate milk. So we're out. We live out here in Rhode Island, and Rhode Island's claim to fame, or one of the Rhode Islander things, because I'm originally from Mass, but I've been living in Rhode Island for like the past, oh man, I don't know. I've lived in Rhode Island the past 15 years or so now, half my life. But their claim to fame is coffee milk, and they have a particular, there's a particular brand. Oh, what is the name of the particular brand? But it doesn't have caffeine in it. At least I don't think there's caffeine in it. But Rhode Islanders love coffee milk. They love coffee milk. It's like a syrup. It's like Hershey syrup, like you would put inside of your milk to make it chocolate milk. But it's a coffee syrup that they put inside of their milk, and they make coffee milk. They love coffee milk out here in Rhode Island. It's the funniest thing. It's funny that you said that. That made me think of that. I got a hole in my lip or something. All right. So creating a link local address on routers. Okay. So link local, we kind of understand that the FE, what that's kind of representing. And again, IPv6 is utterly confusing. Utterly confusing. I'm gonna have to make like a cheat sheet. Maybe that's something I could start doing too, is making like little cheat sheets and putting that up on the Discord as well. Maybe that's something I could think about creating as well, making little cheat sheet guides. Oh, I just pooped my pants. Little shit. Get out of here. All right. The second half of the link local address in practice can be found using the EUI -64 rules. Can be randomly generated or even configured. Cisco routers use the EUI-64 format to create the interface ID. I'm gonna punch you in the throat in a second, you little shit. Get out of here. As a result, a router's complete link local address should be unique because the MAC addresses that feeds into the EUI-64 process should be unique. So, okay. Stop it. Alternatively, some OSs create their link local addresses by randomly generating the interface ID. For example, Microsoft's OS uses a somewhat random process to choose the interface ID and then changes it over at times to prevent for some forms of the attacks. Okay, very good. iOS creates a link local address for any interface that has configured at least one other unique address using the IPv6 address command and the global. Sorry, and I have your psycho. Get out of here. To see the link local address, just use the usual. To see the link local address, just use the usual command that also shows the unicast IPv6 address. So the yeah, we'll take a look at that right there. Recycle, baby.
Did I scare you?
Let's get the poop right out of me. All right, so our link local address. So this is our link local address right here, guys. All right, and we can see how that was generated. Okay, so what it's removing, again, what it's removing is it's removing this portion out of, so it's converting the portion of our addresses here. Remember, it's converting these all down to zeros. Okay, and then it's obviously it's keeping the rest and the rest of our address range. So the FE : because remember it's converting these to binary zeros. Okay, all right, and then it's maintaining the rest of that address there. Okay. So that's how we can kind of understand what it's been talking about with link local. Dude, what are you doing? Hey, I'm trying to study. Stop it. He's all revved up. All right.
Get the poop out of
What do you shoot? What do you shoot? Nerf bullets at me? All right. So we can take a look again what it's actually doing. Okay. So remember, it's removing this portion. All right, this portion of the address. Okay, and then maintaining the rest of that address field. Okay. All right. So what is that there? 1, 2, 3, 4. So the 64. So it's removing that is it 58 or 64? Oh, it's 54, right? Oh no, it's 64 bits. It's 64 bits. It is 64 bits. So it's removing the 64 bits, the first 64 bits, converting that into binary zeros. Okay. All right. That's not 64, Joe. This is 64. So it's 1, 2, 3, 4. So the 64 bits obviously get replaced by the FE and then 0, 0, 0. You have a good night, my good friend. Thank you very much, Gamer Golf. It's been awesome having you. All right. You have a great evening, and I will talk to you soon. All right. Good night, Gamer Golf. Schooled by Maniac Max in Fortnite. It's awesome having you here, my friend, and thank you so much for joining me today. I appreciate it, as always. All right, so that's how we pretty much find the link local address here. Is we're converting the first 64 bits, all right, to binary zeros, all right, and then obviously then we inject the FE80 : because we're abbreviating it down, so that's why we're replacing all those binary zeros now with just : okay. All right, another example right here, guys. So remember, let's remove these first. So 1, 2, 3, 4. So we're removing those first 64 bits. Dude, now it's time to stop. Right now, you're throwing stuff at my computer. Stop, Maxwell. No, I'm serious. I have all kinds of stuff over there, buddy. All right, relax. It's one thing to have fun. It's another thing to get destructive. All right, so that's how we find the link local addresses. Oh, that's how we create the link local address. That's how it's created. Okay. First example, the two pairs of the highlighted highlighted entries in the example for each of the two interfaces that have a global unicast address on gig 00 and gig 000. The output lists the global unicast, which happens to be begin with the 2000 in this case. At the same time, the output also lists the link local addresses for each interface beginning with the FE80. Next, focus on the two addresses listed under the gig 00. If you look closely at the second half of the two addresses listed on the interface gig 00, you will see that the addresses have the same interface ID value. The global unicast address was configured with in this case, with the IPv6 yada 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 6/64 EUI command. So the router uses the EUI-64 logic to form both the global unicast address and the link local address. The interface MAC address in this case is 0201 alpha alpha yada yada yada. So the router calculates the interface ID portion as of both addresses as 001 alpha alpha yada 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 unabbreviated. After abbreviation, router R1's link local addresses on the gig interfaces becomes FE. Yeah, okay, I get that. Because it's removing the 64 bits, and it's abbreviating that down. Yeah. All right. iOS can either automatically create link local addresses or it can be configured. iOS chooses the link local address for the interface based on the following rules. If configured, the router uses the value IPv6 address link local interface subcommand. Note that the configured link local address must be from the correct address range for link local addresses. That is the address from prefix FE80::/10. In other words, the address must begin with FE8, FE9, FEA, FEB. All right. If not configured, the iOS calculates the link local addresses using the EUI-64 rules as discussed and demonstrates in and around. The calculation uses the EUI-64 rule, even if the interface unicast address does not use the IUE/64 command. Okay, so again, it's still going to use that rule to create the link local address, even if you statically configured the complete IPv6 address and did not use the EUI-64 command when dynamically creating your IPv6 address. Okay, routing IPv6 with only link local addresses on an interface. This chapter has shown various variations of the IPv6 address command so far. To review, IPv6 address prefix length statically configures the specific address. IPv6 address prefix and prefix length EUI-64 static configuration of a specific prefix and prefix length with the router calculating the interface ID using the EUI rules. Okay, IPv6 address DHCP that dynamically learning addresses prefix length using DHCP. IPv address autoconfig that's used on the Slack. Okay, dynamically learning the prefix length with routers calculating the interface ID using the IP EUI rules /64. The next short topic completes the list of the following commands. Okay. All right. IPv6 enable IPv6 enabling enables IPv6 process and adds a link local address. Both adds a non-unicast IPv6 address. The purpose of IPv6 enable command will not make sense until you realize that some links, particularly WAN links, do not need a global unicast address. Using the backdrop of the figure, think about the destination of the packet sent by the host, like PC1 and PC2. When PC1 sends PC2 an IPv6 packet, the packet holds PC1 and PC2's IPv6 address. IPv6 address and never contains the WAN link IPv6 address. PC1 and PC2 may need to know the router's local area network IPv6 addresses to use their default gateway, but the hosts do not need to know the router's WAN interface. Okay. Typical uses of the IPv6 enable command. Additionally, the routers do not need to have global unicast or unique local addresses to the wide area links for routing to work. IPv6 routing protocols use link local addresses as the next hop address when dynamically building IPv6 routes. Additionally, static routes, as discussed in chapter 75, implementing IPv6 routing, can use link local addresses for the next hop address. In short, creating a wide area network link with no global unicast or unique local address works. As a result, you would not even need to assign an IPv6 subnet to each WAN link to configure the wide area network interfaces using the IPv6 enable command. Enabling IPv6 and giving an interface a generated link local address. The use command just configure the IPv6 enable on the interface on both ends of the wide area link. Okay. All right. All right, guys, what we're gonna do is it's getting late. All right, let's highlight here. All right, and then we're gonna pick up. We'll pick up back here because we're about halfway. We still got a lot to go through. All right, this is a big chapter, and we spent a lot of time labbing, which I'm really happy about. Again, check out the Git page, guys. This was the newest one right here, guys. This was implementing the IPv6. And again, you can take a look at the configuration here, guys. All right. So this is the whole YAML file. Obviously, we have R1's label. All right, and this is the actual configuration file, guys. This is why it's so neat. You can actually take a look at what we did here. So we have the IPv6 DHCP pool. All right, the address prefix length. Again, you can take a look. All right, and then you can see all the interfaces. So here's our interface, gig 0, our IPv6 address. See what we did with OSPF here. All right. All right, and then you go down, you keep scrolling down, and then we'll get over here. This is R2, right? Yada, 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 loopback, interface. Yeah, this is R2 now. So label R2, now that we're getting into R2's configuration, gig 0. All right, there's some of our addressing, guys, okay? All right, so you guys just, again, you're more than welcome to take a look at what we did. And again, I'm trying to implement more and more things as we go along here to just create, more, I guess, more dynamicy to the stream here, guys, okay? So that's it, all right? So yeah, feel free, remember, if you want, jump on the Discord, guys. The link again will always, here, I'll populate the link one more time in the chat. All right. All right. There's the invite right there, guys. Remember, just go over to the rules. Once you read over the rules, just click that little green checkbox right there, and then you'll be able to see everything else from there, guys, okay? And then also make sure you make yourself over to the welcome corner here, and then take a read over here. This will give you some additional information, and then this is where you can actually assign yourself some additional roles, okay? These are notification roles, guys, notification roles, okay? And I have a description of which each and every one of them means, okay? All right. All right, let's change scenes real quick. Bloop. Mousey mouse to work. Let's go find somebody to raid, guys. All right, who should we go with? Ooh. Let's go say hi to a lady web. All right, let's stick by, guys. Let's go say hi to Lady Web, okay? You guys have a good night. Again, we'll be back here. We'll be back here tomorrow, 5:30 p.m. All right, and we'll continue on with IPv6 implementation, okay? You guys have a great night. Thank you very much for joining me again tonight. And I'll see you guys back here tomorrow. Bye, guys.
Otherwise, you're gonna get your mood right. You always stuck.